Hello, everyone. Thank you for joining today. Uh, my name is Brandon Searle, and I'll be moderating the discussion today. So I'm going to give a quick overview of the webinar, and I think there's going to be some people joining as I do this intro. So I'll take about 10 minutes to do that, and then we'll welcome OD to do his presentation. So yeah, just overview of the webinar. So we'll do an introduction to the Offsite Construction Research Center and Building Transformations, introduce Oliver David Krieg from Intelligent City. Then OD will do his presentation. We'll follow that up with a Q&A and discussion. So just quick overview of using Microsoft Teams in those webinar format. So it's similar to how you'd always use Microsoft Teams, except there's a new Q&A feature. So if you can submit your questions at any time using the Q&A feature in the control bar, we'll get to those at the end during the discussion. If you have difficulty hearing, just check your speaker settings in the audio settings. And if you have any other problems, just message in the chat or Q&A feature, and my colleague Roshni will get in touch. A reminder that all sessions are being recorded and are going to be made available on the Offsite Construction Research Center YouTube page, as well as Building Transformations YouTube page. So a little bit about UMB. We're located in Fredericton, New Brunswick, and the university was founded in 1785. It's home to Canada's first engineering, forestry, and computer science programs, with engineering courses first being offered in 1854. Since then, UNB has grown with campuses in both Fredericton and St. John, over 25 leading research institutes and centers and research chairs, and was even named the most entrepreneurial school in Canada when it was last awarded by Startup Canada in 2014. So a little bit about the Offsite Construction Research Center. We were started in 2019, and then we completed a strategic plan after our 3 years. And we set our values to be industry relevance, collaboration, excellence, and integrity. All that means is that everything that we do when we're working with our industry partners is focused on industry relevance, collaborating both within the industry and across the academic community, and focused on excellence, ethics, and integrity. Our research services, so we have process and productivity improvement that we do. That includes like factory layout planning and simulation and so on. Digital tech implementation and a variety of software and hardware, and lab testing services, which continues to evolve as we get larger. Just diving into our research areas. So again, I mentioned process and productivity improvement. It's kind of a high-level list of what happens there, and it's led by Dr. Zen Lei. Digital tech implementation, again, that's kind of led between Dr. Zen Lei and Dr. Jeff Rankin. Our structures and building enclosure testing, led by Dr. Alan Lloyd. And our benchmarking and innovation in construction work. And many of you may have seen some of the projects we're doing as it relates to roadmaps for offsite construction in Canada and in different jurisdictions. So quickly, just about building transformations. So they've partnered with us to deliver this webinar series. Building transformations fosters industry innovation by providing programs which help our members push the industry forward. Their purpose is to advance civilization by driving the building industry to be global leaders in innovation and technology. They have over 2,000 members, nearly 10,000 in their mailing list. And there's, as you can see here, a nice mix of industry, government, academic institutions. And I encourage you to check out their YouTube page, as they have over 10 years of content on their YouTube page. If you're interested in becoming a Building Transformations member, they have both corporate membership and individual membership, so you can check out their website for that. And then they also have an Innovation Spotlight publication, which I believe they actually launched 2 days ago, and we should see that online shortly. Finally, just their events scheduled in 2025. So 2 of them have happened so far, but coming up in less than a month is an event in Austin, Texas, Future of Design and Construction. And then in October of this year, we'll have an event at the called the Future of Construction Industry Summit AGM and Innovation Spotlight Awards, which is happening in Toronto at U of T. Finally, I wanted to thank our mission partners, PCL, Bentley, and all the others at Building Transformations, and then thank the sponsors at the OCRC, support from the Government of Canada and various departments, as well as our founding partner, OSCO Construction Group. And finally, thank our marketing partners. So this is a variety of associations who we work with to distribute everything that we do at the Offsite Construction Research Center. And with that, I'm going to invite OD Krieg to turn on his video, audio, and OD is going to present mass timber product platforms for scalable urban housing. He is the president at Intelligent City. Welcome, OD.
Thank you so much, Brandon. It's a pleasure to be here. Good afternoon to most of you. Good morning to myself from the West Coast and others who have joined from further away from New Brunswick. I will share my screen here real quick as well. Let's see if we can do this the right way. I'm always very excited to be part of anything that relates to research. My own background is in academia as well. I come originally from an architectural background. I studied architecture. That's sometimes that's a red flag. But I did make maybe a good decision. Halfway through my studies, I became really interested in manufacturing, robotics, programming, and I ended up doing a PhD in robotic manufacturing and timber construction. So looking at the relationship between manufacturing innovation and how that can influence the way we design and build. And in 2017, I got to know the founders of Intelligent City, Oliver Lang and Cindy Wilson, in Vancouver, upon which I joined the company when we started fundraising in 2018. And the company grew from there. The original idea was relatively simple. We want to deliver housing through a product platform approach. We want to develop a configurable kit of parts, a configurable product, if you want, from a scalable and repeatable platform. And we want to industrialize construction along with that, because in order to deliver configurable kits of parts, we need a certain flexibility in manufacturing automation in order to customize building components like that. And ultimately, with all of that knowledge, it also invites automation and software to augment the design, the planning and delivery of buildings, and to ultimately create a data flow or common data environment, if you want, to seamlessly transition from design to manufacturing. So from 2018 onwards, I joined the company and as CTO, and I recently took over as president. As the company matured, I think it's a natural step to build a leadership team. And I'm only doing this because we have a really good leadership team from construction or mass timber, project management, business development, where we really combine all of these ideas into a large operation. And while we are only in Vancouver right now, we have projects across Canada, and we are trying to expand into other provinces as well. We're all here for the same reason. I don't have to repeat that probably. We are facing a whole bunch of challenges. Developers are facing mostly those challenges, and it's up to the developers often to figure out a way to build nevertheless. And while maybe the incentives are different, the problems are the same. And it's kind of fascinating to me as a someone coming from Germany, having moved to Canada, having the Canadian citizenship now. It's fascinating to me to have gotten to know a different country and how they approach problems, how they see what they can do with their resources. And it is, it's just been an incredible journey the last 7 years for me to see how not too recently mass timber was approved in the building code. I think it was 2014. And to have seen how quickly it has gotten adopted, how much people are really trying to make it work. We have the resources in our country. And last time I checked, the amount of available or the amount of forest that is approved for harvest, which is a sustainability calculation, right? You're not harvesting more than is regrowing. That amount would allow us to build all residential construction 3 times over every year. So we have the resources. They might not be very accessible, but there are ways to cultivate forests for harvesting in a sustainable manner. We can see it in Europe all over the place. And there are many ways to innovate in construction to make it more systematized, more organized. But it comes with challenges, and that's what I want to talk about today. I don't want to talk only about Intelligent City. Really, I mean, obviously, I want to present to you what we are doing and how we are approaching it, but I do truly believe that we all have to upskill and find strategies with which we can accelerate the supply of housing or any building that is needed. Why is mass timber so interesting, and why did we choose mass timber? It has many different reasons. The first one is a little independent from mass timber itself, but ultimately mass timber came in as the opportunity. We are seeing, as you probably all know, a lot of mid-rise densification in North American cities right now, and it's a bit of a realization, I think, that cities are coming to. We don't have to build 40, 60-story towers to make a city affordable. All we have to do is build somewhere between 6 and 12 stories, and that is a level of density in cities that allows for the economic development of urban infrastructure. And that's ultimately what cities are about. You have to have enough people to use the public transit for public transit to make sense. You have to have enough people, for stores, for community centers. And if you reach that critical mass, you have a very livable city, and you shouldn't go over it either. Otherwise, it becomes too dense, too crowded, too dark. And that's exactly where this mid-rise densification is best situated. And we're seeing it in Toronto, along the arteries. We can now build 8, 10, 12 stories. We can see it in Vancouver, the Broadway plan and the Vancouver plan allowing for higher buildings around transit centers and along the main arteries. That's exactly the level of density that it makes sense. Now, at the same time, it is really mass timber that becomes very competitive in that area where stick frame isn't possible anymore, and concrete may still be too cost prohibitive to build a building that is 8 stories high. And especially around the 8-story is where mass timber is particularly helpful right now, because that's where, according to the latest codes, we don't have to encapsulate it. So at 8 stories, you have pretty much this picture. Even though this is a construction site, this is also what it could look like at the end. This is from one of our mock-ups from a few years ago. That's why you see the cross bracing here, because there's no shear wall. But essentially, you have exposed ceilings, you have exposed walls if you want to, and exposed columns, and you don't have to drywall. So not only is mass timber construction and mass timber prefab construction slightly cheaper than concrete, you also save other trades and materials now, and there are other advantages that come with the material, such as a more biophilic environment, a very beautiful material to look at. It has proven to balance moisture levels and the atmosphere in your apartments. And it's a very good material to work with, of course, especially in prefab. It's easily machinable. It's a very clean material to work with, and it's lightweight enough to move around a factory more easily and to move around on trucks more easily. At the same time, there's also really an opportunity in Canada to enable the mass timber value chain. Intelligent City has gotten many grants from the forest sector because of the opportunity to value add and to reduce the amount we are exporting lumber and pulp, and to instead use the materials, make them into CLT or other mass timber parts, and ultimately go even further, make them into building components, which are of course much higher value. And there's a lot of opportunity here to export building components as well, right? So we are kind of pulling the supply chain and we are pushing on the demand, and hopefully we can assist in renewing our mills, renewing our forestry, getting more mass timber plants. I believe there are two companies currently planning new factories on top of the existing 4 CLT suppliers in Canada. And generally, if you look at the curve, it's going rapidly upwards. There's no reason why mass timber should be more expensive than any other construction method. The way we have looked at it, in fact, it is cheaper if done right. And maybe that's one lesson here today, is how to do it right. And also probably that across most provinces, and probably soon all provinces, the EMTC is adopted. Many states have adopted the IBC, and this is already over a year old. It might be already more blue and more green at this point. And there's also updates to the EMTC coming and to the IBC, where the code's considering going above 18 stories even. Although, to be honest, I don't think that's really that important. 18 plus story buildings are quite rare still. And we want to focus on the masses. We want to focus on producing as much housing as possible. And that's really in the low mid-rise segment. Now, I mentioned product platforms before, and I want to talk 5 minutes about that. So maybe that's the little teaching aspect to this presentation, but I think it is truly, truly important because our industry, for some reason, has been pretty detached from many other methodologies that have been used in other industries. And product platforms are a very smart way to try to make as many variations with as few parts as possible. That's literally your KPI. How many product variations can you achieve with how many parts? Kitchens are a great example. Kitchens have a base element, the cabinet. It's actually an industry-wide platform, not only within a single company, like car companies all have their own platforms usually, but a kitchen is actually industry-wide. It just proved to be so beneficial to stick to a certain dimension that all kitchen suppliers have more or less agreed to using those dimensions. So you have the base platform, you have specific core elements that are uniquely different from each other, and then you have variants of those. If I use the laser pointer to use that, yeah. Then you have then you have different variants of those core elements. And then you also have complementary elements that are usually not supplied by the same supplier, but they are complementary to what the supplier supplies, and the interfaces between those are standardized. And so everyone knows I can get any stove that I want from any supplier, and it will fit into my kitchen, right? And now you configure the project, quote unquote, if you will, the finished kitchen, right? And so no kitchen has to be the same. You can reconfigure that, and it'll always work. And you have in every element that you used here, the manufacturing information is already known, right? The engineering is already known. That is the opportunity that we have. Now, of course, kitchens are very simple compared to whole buildings, and we'll get there in a second. But one thing that really, truly changes that we should think about is when you stop thinking about project-based and you start thinking about product-based, pretty much everything changes. A project is a temporary and unique endeavor, as I wrote here. You think from start to finish, whereas a product is a permanent good or service that has life cycles. Your goal is not completion, your goal is consumption. Your metrics are not completion, cost, and acceptance. Your metrics are sales, revenue, satisfaction. Your requirements are iterative. And your team is continuous. And the scope is continuous as well. You go through iterations, you update the product, you release it another version that is better or can serve a larger market, right? Or maybe it splits off into different products that serve unique markets. And so your goal is that you have it all figured out and you can sell multiples of it, right? And that is a very different approach to how we see projects usually, especially, I think, especially in the team segment, as you can probably all imagine, and as the experience that you have working on different projects with different teams. The amount of information we lose and the communication that we struggle with if we have to imagine every time they build a new Volkswagen Golf, they have to find completely new teams to do it. You would not get to that continuous improvement that we see in other industries. Other notable examples, of course, as I mentioned, are cars, and we talk a lot about cars and how we don't build our cars in our driveways and so on. But obviously, we don't do that because cars have wheels and they can drive and they can come out of a factory. Houses and buildings cannot drive, so we do have to assemble them on site. But there are certainly some aspects that we can learn from. Lego is also a good example, but neither of these really show or have a solution to the problem that we are facing in our industry. And that is the unique geometric customization that we need to do. We don't go to a Volkswagen dealer and say, I would like a Golf, but I would like the Golf to be 2 inches longer because my garage is 2 inches longer and I would like to make use of the garage space, right? It's expensive real estate. I don't want to lose those 2 or 3 inches. I need to fill it up, right? That's how developers think. And we don't have that option. You don't go to the car configurator and change the car shape. You can choose between different products. And the reason for that is obvious. The car manufacturing process doesn't allow for that flexibility, and we've all accepted that constraint. And instead, many different companies have come up with different products that fill as many of those gaps as possible, right? But they are distinct products and distinct versions. And there are enough out there to fill the sort of needs we have. But buildings are a little bit different because even if you want to develop a building product or building as a product, really just rubber stamping that across the country will not get you enough projects or enough market to really make sense of that. So you do need that flexibility and configurability. And so the way we approach this internally, this is actually an internal slide, but I really like it because it kind of just exemplifies the thinking of what are our sub-assemblies and what are the variations in there. And you can see, for example, on the cladding side, there are variations. Yes, you have different window boxes, different cladding colors and types. But when you go towards the back, for example, of our envelope panel, there isn't just 1 or 2 different versions. What really is the variability here is the geometry, is the length and the height of a envelope panel, and that remains flexible. So no matter what you choose, there needs to be a certain geometric flexibility here in the back that allows you to adapt to whatever building shape there is. There are constraints, of course, and there are more constraints than we have currently with traditional on-site construction. But you still need some sort of flexibility here to adapt to these different building shapes. And that is ultimately sort of what we define as our product platform. It's a very flexible, we want to call it parametric, although that is a bit of a stretch sometimes. A parametric product platform that has core elements. And this is, for us, the core elements are what we make. We manufacture envelope panels. We manufacture the structure of the building. These are floor cassettes. I'll talk about that a little later. And we also integrate mechanical and electrical services inside the floor cassettes. That's a unique thing. And these are the ones that we manufacture, we control, we understand 100% what they cost and how they function. Part of a product platform is always manufacturing and software and people, processes. And then we have complementary elements. Those are exactly like before in the kitchen example, elements or components that we don't manufacture, but we want to interface with. And good examples are bathroom pots. We would like to build an ecosystem of suppliers that make bathrooms, that make interior partition walls, that make balconies, and other parts of the building that we can prefabricate and put on site and assemble instead of construct. And this is a journey. We haven't figured this all out, especially in the complementary element side. We have not engaged with bathroom part suppliers. It has huge implications on our apartment layouts. And as you can imagine, there's all sorts of requirements that come from developers. What really needs to, how does the building need to look like to make sense for a specific market? And so there's a lot of back and forth still trying to figure out what exactly it is. Like, how can we standardize it a little bit more? You can imagine with bathrooms, well, there are only that many versions you can make. You don't have to scale a bathroom parametrically. You just have to figure out there's a, a 8-foot version and a, the orientation is flipped and so on. So you end up with like maybe 6 different bathroom variants. But when it comes to the overall structure of the building, you have infinite variation, right? And so from that platform, we have our product family that we split up into different heights of buildings. I'll show that in a second. And then you always have bespoke elements. There's always some aspect, underground parking, commercial spaces, landscaping, rooftop amenities. No building is the same. So even if we have everything somehow figured out and systematized, you will always have a certain amount of localization that ultimately gets you your individual projects. So from there, to get to all of these different buildings, that is really the secret that I think our industry needs to figure out. What is the smallest set of common elements that you can develop in such a way that you can serve such a big market segment? In our case, mid to high-rise urban housing. Whoever figures that out, I'm 100% sure about that. Whoever figures that out will build a very, very big company. That is really the secret. And the problems and the challenges we are facing to get to that point as an industry is simply related to an acceptance, an understanding of that approach, and of course, also permitting. Different jurisdictions have different requirements, right? And I think there are many initiatives out there right now trying to figure out if we can find a common set of building typologies and designs that get pre-approved. It's a huge step. If we get to that point, now suppliers can start developing their building systems around those. And that will ultimately allow us to boost this idea of manufactured building components. I do want to mention it quickly. I'm pretty sure there will be questions about this. What about design freedom? What about the uniqueness of the buildings that you have? Absolutely. We are founded by architects. Many of us have an architectural background. The whole idea is here that we figure out these systems so that they allow for that design freedom, right? We don't have a single building. We have a single type of cladding, a single type of balcony system. We want to enable that flexibility in many different ways. But if you ask us what is the product ultimately, well, the product is, the family of products, we like to divide it into those 3 different heights. Low rise, 3 to 6 or 5 to 6 stories. Ideally, I think we're really competitive 5 to 6 stories, where we compete against stick frame. Here, you might have sometimes a bit of a 5 or 10% cost premium, but you also get a higher quality building. When it goes to 7 to 12 stories, our experience so far has been that we are cheaper than concrete. And then when you go to 13 to 18, you might be on par with concrete depending on the specific building design and the structure of the building. The lateral reinforcement just becomes a little bit more complicated. But ultimately, we are configuring a product instead of designing a project. And so ideally, I have to say, this is a bit fast forward a few more years. We haven't figured all of these aspects out, but ideally you go through massing, yield, performance, structure, facade customization, accessories, and interiors. And there are a certain number of options that you can pick from, and then you have configured your building, and we're good to go. Fundamentally different from how things are going today. And I will say this requires a lot of things to fall in place. An intelligent city is not that vertically integrated either. We see ourselves right now as a collaborator with builders, with architects, with engineers, because we are neither. We are not an architect, we are not an engineer, we are not a builder. We manufacture building components, and we like to look at the whole building because it's really important to look at the whole building when you design with prefabricated systems. But we need collaboration. We need the architect, we need the developer, we need the builder to work on this with us for these buildings to be successful. So our solution to this is threefold, as I mentioned in the very beginning: customizable building systems, automation in manufacturing, or simply manufacturing. I would argue just the fact that we adopt manufacturing principles, which means you have an assembly line, you have a certain level of standardization in your processes. You don't retool every time you build a new building, but the assembly line is able to adapt to the different design customizations within that logic. And then ultimately, once you have that, you can also automate the design process, or some of the design process, especially the back end of manufacturing data generation. So you start building a software environment where you design a building and you get to manufacturing data really quickly. So this is how it looks like. Ideally, this is what the building design can look like. This is pretty far-fetched, and oftentimes it doesn't work, so I'll say that, but this works. The production of building parts, the building parts generate machine code, and then we can execute in our factory. So last year, we started production on our first project, delivered it at the end of last year. We're now on our second project at the moment. But just to show you sort of some impressions from our factory, some robotics here, we're machining the parts ourselves, put them together with some robots, and then a lot of people. That's really an important part here. We're not automating 100% of the process. There's a lot of other things that are happening manually. And then this was a 9-story building in East Van for the BC Indigenous Housing Society. So this is a pretty big deal. This is a very important project. To the Indigenous Housing Society, bit of a lighthouse project. You can see the cladding here. He is hinting at a basket weave pattern. It was extremely complicated. We would not like to do that again. That was a puzzle. And you can see on the right-hand side, the building is black. That's because on the front, it will get an offset screen that will continue that basket weave. So quite excited to see that happening. I think the building will be done this summer, move-in ready. So I'm pretty sure there'll be some big announcement about that. But we came in late to this project. This was an opportunity for us to kickstart our production and to kickstart our sort of commercial operations. And it was only envelope panels. It was not the structure. It's actually quite funny. You can see how here in the center picture, on the bottom, our envelope panels have a different CLT than the ceiling. So it's a kind of a color change. Doesn't matter because the building was designed and permitted a few years ago, and it's completely encapsulated, unfortunately. So you will not see any of the timber anymore. It's quite unfortunate, but this is sometimes how these design processes go, especially when they go for a long time. But we came in late, and we were able to slightly catch up with our envelope production, ramp up that into our factory, learn a million things, as you can imagine. When these things fly through the air and get assembled, there's a lot of things we learned. But one thing that worked was that the panels fit, and they were all installed, 122 of those. Very successfully. This is a passive house building. So far, all the testing was successful. We had tested these envelope panels on mock-ups a couple of times before, so we were not too surprised about the performance, but it was certainly an incredible opportunity to work with Ventana Construction here and many other engineers and consultants, GBL architects on this particular building. What we are working on right now is a project in Toronto. It's also a 9-story building. It's also around 50 or 60 units, a rental building with windmill and leader lane developments. This is fully our product, how we would like it, applied, basically. The design of the building is actually a little bit special, I would argue. It has very small units, 350 square foot studio apartments. But the way we have wrapped the structure around a concrete core and then the envelope around that is relatively efficient. We have about 100 of these floor cassettes that you can see here in the picture and 100 envelope panels. And we're starting assembly on site in May. And if things go well, we are planning this to go up in 80 days. 9 stories, structure and envelope. Building is enclosed, starting in May, finishing in July, and then they can finish the interiors. Which is also really interesting for climates like Toronto and Ottawa, and I'm pretty sure most of the East Coast, Calgary too, where you have a cutoff date with concrete, right? And you need the structure to be done. Ideally, you want to have it enclosed before the winter comes. And so having the opportunity to set up the structure and the envelope really quickly and then focusing on the interiors afterwards allows you to time the construction really well in these climates and also just work a lot faster. Other projects are coming up. We won a competition for an 18-story housing project in the Okanagan with BC Builds. That will likely start construction end of the year or early next year. That's a really amazing opportunity, of course. It's a huge building, and it just is exactly what BC Builds wants. They want housing, they want it fast, they want it efficient. And this is where systems like those really shine. So from a customer perspective, it's actually quite similar to anything else because we are just a supplier ultimately. So one thing we like to do is go through a feasibility phase where we simply evaluate if the building works. If there is already a building design, early phase, development permit or something like that, we can just analyze that really quickly and see if the grids work and the facade works, if there's anything we need to change, and sort of give it a score and say, there's a few things we need to maybe adapt, but then we could employ our systems. If there is no building, a developer can come to us and ask basically to see what the yield could be, how many apartments can we fit, what's the massing like. So sort of what you see on the left. And then we go through the planning phases, which are just the typical planning phases, except they can be accelerated if we use some of our standard apartments. They're all pre-planned. We can employ them really quickly. Otherwise, we just go through SD, DD, and CD phases with the architect, and we basically do a design assist process where we guide the design of the building so that our systems can be applied. And then the execution, of course, is also quite fascinating because we ultimately get to a much faster construction process. Based on accelerated design, we can start sooner, but of course we can also work in parallel with on-site construction, especially if you do underground parking. We start production when the construction starts, and by the time our components are needed, we are 2/3 through our production cycle, and we can start the delivery and then accelerate the construction usually by at least 2 to 3 months. And that's what the 80 days will approximately look like. In high-rise construction, it depends a little bit on the market if we do a concrete core or a steel core. Honestly, a steel core is better because steel cores can be assembled with the mass timber. Concrete has to be finished before the mass timber comes in. Because of the formwork going up and people working on the top, we have to wait. But nevertheless, that's what we're doing right now as well. A concrete core goes up. Once that is done, we come in, we put the floor cassettes down, the columns, and then 2 levels behind, we start putting in the envelope panels. And so in a relatively large building like this one, you have 1 or 2 or 3 days per floor for the structure, and you have 2 or 3 days per floor for the envelope. And you can work in parallel, and so that's what allows you to really accelerate the assembly time of the building. And one other aspect, talking about mass timber, passive house, operations, you simply reduce your GHG emissions completely, especially compared to what code minimum was a few years ago. This delta will probably balance itself out a little bit over time as the building code is also increasing energy efficiency. But ultimately, it is the embodied carbon and the operational carbon. And when we look at urban densification, it's also the behavioral emissions that people have. If they have their own car versus they use car sharing and urban infrastructure instead. And so if you don't have parking in these buildings, our buildings can be carbon neutral or carbon negative over their entire life cycle. And so just looking, that this is actually possible with today's technology is incredibly encouraging. There's no magic involved to make buildings carbon neutral. We just have to be very careful with the embodied carbon, and we have to have very energy efficient buildings and ideally use renewable energies. And we get to carbon neutral cities. And for developers, there are a few aspects to this. The time savings is one, and the operational cost is another one. There are many other smaller aspects that I'm ignoring right now, but ultimately you can get to a cost reduction of your investment needed of up to 20%. And you get a building that is a higher value, potentially higher rents or sales, but also lower cap rates because of the building life cycle, the ESG compliance, and the carbon neutral aspect. There are obviously other potential benefits, such as carbon credits, that we're not including here right now. So a few more slides about the development process. So just want to show you a few more details about how it really looked like when we developed these systems. So I mentioned the floor cassettes earlier. We are looking at the structure of the building a little bit different. Because of manufacturing requirements and our ambition to implement more services inside a flat packed prefabricated component, we ended up developing our floor cassettes so that it is a double layered system and it can have services inside. So the top and the bottom of this floor cassette here is part of the structure. It's a sandwich panel basically, and it's made of smaller components. You can barely see it here. And inside of it, we can put mechanical and electrical services. But that also has implications on the grid. I'll show that picture in a second. And then the envelope panel is a curtain wall system that hangs from the building edge. So it is similar to most curtain wall systems, except that it has a mass timber structural layer that is also at the same time your inside wall, right? Your inside face doesn't have to be encapsulated with drywall and so on. It can just be the timber face. And then the outside is the same as any other curtain wall system that you have, membrane, insulation, cladding system. Different types of claddings are, of course, possible. What you see here is 8 inches of insulation. It's very thick. It's a passive house design. Doors and windows are included. Cladding is included, all finished. It comes inside. The only thing you have to do is stitch the cladding. You can see it here. There's one piece of cladding missing between the panels. It gets slid on from the top. You don't need any scaffolding, and you close up your envelope already simply with these gasket systems that we have developed here on the sides. For the structure, what I mentioned earlier, this is really sort of the important aspect, is that our floor cassettes are not just randomly laid across the building, but they are actually laid out in the way that the apartments are laid out, because they need to overlap as much as possible with an apartment logic, so that the services that we run inside these floor cassettes are actually very controlled and as much inside a single floor cassette as possible. So you have a single floor cassette usually is a studio or 1 bedroom, 2 floor cassettes can be a 2 bedroom, 3 floor cassettes can be a 3 bedroom, and so on. And there's different variations of this. We are still learning exactly what our apartment library, quote unquote, needs to be. But it is very clear that in our system, as well as in all mass timber, I have to say, looking at the grids is just very important. You just have to make sure that your columns and your grid are very rigorously placed and they overlap very nicely with your apartment layout. Otherwise, you will run into issues later on. It's not as flexible as concrete or stick frame. You have to look a little bit more at the structure of the building together with the layout. So you're already kind of forced to integrate a little bit more. Then, as I mentioned, with manufacturing, we really looked at what are the parts that require this sort of level of customization that is really hard to do manually, and also what are heavy things that we move around, where automation is really helpful, loading, unloading, moving materials. We glue, we nail. There's a lot of things that our robots are doing, but ultimately, our factory is still quite small and still quite manual. So you can see here in the center is our milling center. That's where we are sort of processing stock CLT and other timber materials. And then in the very back here, you can barely see it, is our floor cassette production. That's about 80% automated. We make 1 or 2 floor cassettes a day. And then here, this area in the front here is our envelope production. And you can see here that there's, these envelope panels, they hang from a steel frame. That's all manual work, insulation, cladding, it's all manually done. There are ways to automate it, and we're very excited about them, but they require space and money. And so this is more like a long-term, gradual transition. We'll keep the same amount of people and we'll add more robots to them and increase output capacity, sort of like that. And then my last point is about software and data flow. I think it's really important that Canada upskills in terms of BIM and standardizes the way we engage with building designs. We see it sort of in 3 different steps. That's how we divided up our software workflow generally and our workflow internally. You have the design intent, which you can see here is normally looks like that. There are boxes or surfaces and curves that indicate what the building is supposed to look like. But in the background, what this does is it generates our BIM model, it generates our components, and that what I mean with that is the actual building parts, right? A piece of CLT, a screw, an aluminum extrusion, and that is modeled like it is being built. So it's not a continuous profile. If it's 10-foot segments, it's 10-foot segments, and things like that just have to be taken care of so that we can use that then for manufacturing data. And so that transition is really important that we have, like in this upcoming project. We have the model of our building components, structure components, and envelope components. You take one of the envelope panels, it generates all the parts, the shop drawings, the manufacturing information, pretty much automatically. And that's a really important, it happens all in the back end, no one can see that. But for us, that was the most important part to start. The sort of the front end here on the left side is something that is beneficial when you iterate through building designs, but oftentimes it's pretty clear, especially in urban environments, what the building needs to look like. There's usually just one singular solution anyway. So it's not so much about going through 1,000 different building iterations. It's much more about automating what comes once you have your design model frozen. So last year was a very exciting year for us to build the first building, to see these panels come together in real life on the 6th floor, 8th floor of a building while it's raining, to see how everything works, to see the team work together. We are about 50 people now. Half of that is manufacturing staff, the other half is management, engineering, and so on. And now we are just looking to expand. We are seeing a lot of opportunity on the East Coast or just Eastern Canada in general. Everywhere, literally every city has the potential to densify the urban environment, to build 6-story buildings, 8-story buildings for housing. We are seeing that in Calgary and Edmonton. And we just want to find partners that can work with us on these buildings, that can help us make these buildings happen quickly, that really need housing, that really need to build quickly, and want to showcase that mass timber and industrialized manufacturing really works. We can see it every day. I'm very convinced that it works. I'm very convinced that if we don't do it, someone else will do it. And I think there will be many companies like us because there's enough housing out there needs to be built that we need 10 intelligence cities and not just one. So I'm not concerned about competition. I'm concerned about everyone working together to find the right solutions. We are happy to learn. We are happy to adapt because we are, not more knowledgeable than anyone else. There are many different solutions for the problems we have, and we want to find the right one and use that to build a lot of housing. That's really our mission. So thank you so much.
Thank you, Odie. That was a great presentation, a lot of information. I'm just looking at time. We have about 7 or 8 minutes for questions, which is really probably enough time for a couple questions. I have questions and maybe a question to kick something off. So on one of your slides, Odie, you mentioned vertical integration and how you guys aren't completely vertically integrated, and you and I have chatted about this before. We had a presentation done by DPR Construction based in the US back in December. And they mentioned, so they have some organizations which they own and are vertically integrated, but they also have strategic partners across the US or really across North America and suppliers depending on the geography and where the project is located. I was just curious if Intelligent City has looked at like a macro level strategy for vertical integration and alignment with product suppliers, and if that varies across the different parts of Canada.
So for us internally, I would say yes, absolutely. Because if we work on the West Coast, we would use CLT from Kalashnikov or Mercer, and when we work on the East Coast, we will use Element 5 or Nordic. Things like that, window suppliers. We don't want to order windows from the East Coast, ship them to the West Coast, and then ship the components back to the East Coast. Any solution in our industry has to be localized, at least maybe in the 4 quadrants in North America, right? But probably more really province by province and state by state. If we go sort of outside of Intelligent City, I would say we are at the very beginning of reaching out and finding collaborators, because for us to make this all possible, we need a building partner. We need engineers and architects who know our system, who can work with our system really quickly. And ideally, we want to integrate with them. We want to have a really good data sharing policy so we can really quickly design buildings. And the builder knows how our systems work. They know what the construction cost of the overall building will be with our systems. And that's ultimately what's needed for a developer to make a decision. So that's really important to us. We have a partner in Toronto, Open Build. We actually don't really have a partner yet in BC. And so everywhere where we go, we want to build a building. We are looking for partners. So PCL and other big construction firms are very interesting for us, because we would really like to form partnerships so that we can continuously work on different buildings with the same team.
Oh, thank you. That's great. Now, the other question I had, so and this is top of mind just for some of the things I'm working on right now, but you had showed, I think, the kind of scheduling benefits and how that results. Obviously, time is money, and being able to end the project sooner is better for the developer. And I think we kind of pitch that with any offsite solution, whether it's volumetric modular or precast concrete or mass timber or whatever it might be. I was just wondering, just based on the projects you've done to date, has there been many lessons learned in terms of how like the financing hurdles or the insurance hurdles that you need to overcome in terms of data sharing and different things like that across the supply chain? Have there been lessons learned that you're able to share?
Well, in terms of scheduling, I would say one lesson that we have learned is that it is a lot more complicated than you would think it is, because the GC really has to make sure that on a day-to-day basis, they know exactly which trade needs to be where. And even though it's fast to put these components together, once the components are put in place, you have to stitch them together. You have to do fireproofing. They have to be signed off, and there are a lot of little things that have to happen on a daily basis that you really have to sit down and look at the schedule very, 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 very detailed. In terms of insurance, prefab and mass timber. So there's a few aspects to it. Our components are CSA certified, so that means our factory inspections are standardized. There's an inspection in our factory, an external inspection in our factory 3 times a year. So when our components come out of the factory, they have a certain level of rigor and quality control that is sufficient that you don't have to inspect them on site anymore. However, that is still a bit of a learning curve here for everyone involved, for consultants, even for the city. That the city inspector, it's probably the first time that a city inspector would actually see a prefabricated system. It just doesn't happen that often yet. And so our strategy to mitigate that is to be very upfront. And we're doing all of our QA/QC in an online database, and we can extract information from that. So every component comes with a certificate of conformance, we call it, and it has a lot of data in it, and it shows like here was the wood moisture that we measured when we put it into the CNC machine. Here are photos from the membrane, here are photos from the insulation, and all of these things are in there, and they can be accessed if needed, so that we kind of build that trust, because it is just still a very new thing, even if the CSA certification, the A277 for factories that manufacture, building components, has been around for many, many years. It just hasn't happened often enough for consultants and building inspectors to be familiar with that.
Yeah. I think as projects become more complex, I think I've heard discussion of CSA looking at the A277 because now it's being applied to different factories that are taking on much more complex projects that have different processes and larger teams and things like that. So I wouldn't be surprised if that revision comes down the line. My last, I don't know if anyone had any questions. I'm mindful of time and we're going to be wrapping up in a couple of minutes. But my last comment was just around, so you made a comment around Canada needing more BIM design for manufacturing and assembly skill sets. I'll do a little plug to say that we are in the process of developing a program with 2 courses in that area. But I guess just is there anything like specific that you think should be included? I know it can differ from panelized to volumetric to mass timber to precast, and being an education facility, we got to be able to train them for all sorts of that. So is there any kind of low hanging fruit suggestions you would have for teaching and educating the next generation of engineers and architects and so on in DFMA and BIM?
I think, generally upskilling and making sure that every consultant in the future, works in 3D BIM is just a fundamental thing that would already help us a lot in general. But in specifically in terms of teaching, I think what's important is to distinguish between a design model and a model that is meant for manufacturing, right? Because the way architects usually design in Revit is to just have a continuous wall assembly, a floor slab that is just one floor. And the big sort of hurdle oftentimes is that is completely useless. And now you have to remodel everything because you have to actually make a floor cassette that has a specific dimension that fits into the grid. You have to make an envelope panel that is only 20 feet long or 28 feet long, and you have to cut it off, right? It's a single component. And making sure that A, we understand that difference, and B, we prepare ourselves when we model that it is easier to transition into that, right? And it's easier to have a higher level of detail in the model from an earlier phase onwards, and you have more integration. I think plumbing and mechanical and electrical are sort of those 3 disciplines together with architecture and structure. They have to really work together from the beginning to make this work. And usually we simply enforce that, quote unquote, by providing our models and saying, here's a floor cassette, and now you know where the floor cassette ends and where it starts, where you can penetrate it, where you cannot. And that just creates that sort of precedent in a way. So that really helps to enable the whole team to think more detailed about how everything comes together.
Oh, great. No, that's very useful. And I might be in touch for a letter of support as we go through the approval process of this program. Some of my colleagues are on the call, so I'm sure they're chuckling at me saying that. All right. So just to wrap up, I want to thank you. I know you're a busy guy and there's a lot on the go, especially as Intelligent City continues to grow. So we'll keep an eye on that. And I'm sure there'll be more collaboration opportunities for the audience. Our next presentation is next month, and it will be volumetric building companies. So that's Jill Kaler, who's VP of Design, and Sam Bailey, VP of Pre-Construction, will be presenting. So hope you can join us there. And just I wanted to thank you again to our partners, the Government of Canada, as well as OSCO Construction Group. So thank you, OD, for your time today, and we'll talk soon. Take
Thank
care.
you so much.
See ya.
See y'all.
Bye.